Picture a predator built like nothing else that has ever hunted on Earth. A face short and deep like a bulldog's, two thick horns jutting from above its eyes like a bull ready to charge, and arms so small and useless they barely belong to the same animal. For decades, paleontologists believed something like this was too strange to be real. Then, in the Badlands of Patagonia, Argentina, one nearly complete skeleton proved them wrong and rewrote what we thought we knew about how predatory dinosaurs could look. This is the skeleton of Carnotaurus. Today, we're digging into the complete story of this bizarre, horned killer, the single specimen that built its entire scientific reputation, the astonishing fossilized skin that came with it, the ongoing debates about its tiny arms and blistering speed, and the man who pulled it from the ground in 1984. This is the complete story of Carnotaurus. The name Carnotaurus comes from Latin, carno meaning flesh or meat, and taurus meaning bull. Put together, the meat-eating bull, a direct reference to the two thick horns rising above its eyes, unlike anything seen on any other predatory dinosaur. Carnotaurus lived during the late Cretaceous period, roughly 72 to 69 million years ago, prowling what is now Chubut province in Argentina. Back then, this region wasn't the dry, wind-scoured desert it is today. It was a warm, semi-arid floodplain, crossed by rivers, dotted with lakes, and home to a strange mix of dinosaurs, crocodile relatives, and early mammals found nowhere else on the planet. It measured roughly 7.5 to 8 meters long, about 25 feet, and is estimated to have weighed somewhere between 1.3 and 2.1 tons. That makes it a mid-sized predator by large theropod standards, smaller than an animal like Tyrannosaurus, but every bit as formidable, with a deep, narrow bite built for a fast, powerful bite. Carnotaurus belongs to a family of dinosaurs called the Abelisauridae, a group of predators that thrived almost exclusively in the southern supercontinent, once known as Gondwana, in places like South America, Madagascar, and India, while tyrannosaurs dominated the north. It's one of the reasons Carnotaurus looks so alien to people used to seeing T-Rex. The two groups evolved on separate continents, solving the same problem: how to be an apex predator in two completely different ways. A question worth asking before we go any further: how do scientists actually know this skeleton is around 70 million years old and not some far more recent age? The answer, as with most dinosaur fossils, comes down to two tools working together: stratigraphy and radiometric dating. Stratigraphy is simply the study of rock layers. Sediment builds up over time in a predictable order. Generally speaking, the deeper a layer sits is older relative to the layers above it. Carnotaurus was found within a specific unit of rock called the La Colonia Formation, a sequence of reddish and greenish mudstones and sandstones laid down by ancient rivers, floodplains, and the edges of a shallow sea. To turn that relative position into an actual number, scientists rely on radiometric dating, measuring the decay of naturally radioactive elements found in volcanic ash and mineral grains that are sometimes preserved within or near the sedimentary layers. Combining these two methods places Carnotaurus firmly in the very late Cretaceous, just a few million years before the asteroid impact that ended the age of non-avian dinosaurs altogether.
If there's one feature that instantly identifies Carnotaurus, it's the skull. Short, deep, and almost box-like from the side, it looks nothing like the long, narrow snouts of most other large predatory dinosaurs. Above each eye sits a thick, cone-shaped horn, not sharp like a rhino's, but blunt and heavily built, more like the horn of a bull or a bison. No other confirmed theropod dinosaur has anything quite like them. Paleontologists still debate exactly what these horns were for. Some believe they were used in head-to-head combat between rival males, either shoving or ramming one another, the way modern bighorn sheep or muskoxen do today. Others argue they were primarily a display feature, a visual signal of strength, maturity, or dominance, meant to be seen rather than used in violent contact. Despite its bulldog-like shape, the skull of Carnotaurus wasn't necessarily built for raw crushing power. Studies of its jaw mechanics suggest it likely had a comparatively weak bite for an animal its size, but was capable of opening and snapping its jaws shut with remarkable speed, a hunting strategy built more around fast, repeated slashing bites than a single bone-crushing clamp. Everyone remembers Tyrannosaurus for its famously small arms, but Carnotaurus takes that trait to an entirely different extreme. Its forelimbs are even more reduced than a T-Rex's, ending in tiny stub-like fingers that appear to have had almost no muscle attachment points at all. In fact, of all known large theropod dinosaurs, Carnotaurus may have had the most vestigial arms ever discovered, so small and so structurally weak that scientists still aren't entirely sure they served any function at all. Some researchers have proposed they may have played a minor role in mating behavior, or perhaps in balance while the animal moved. Others suggest they may simply have been on their way towards disappearing altogether, an evolutionary structure the animal was actively losing rather than actively using. Whatever the answer, the arms of Carnotaurus remain one of the strangest anatomical puzzles in all dinosaur paleontology. Proof that evolution doesn't always build towards usefulness and sometimes leaves animals with features that are quite literally going nowhere. Here's what truly separates Carnotaurus from almost every other large predatory dinosaur ever found: skin. Preserved directly alongside large portions of its skeleton were extensive patches of fossilized skin impressions, an extraordinarily rare discovery for a theropod of this size. That skin revealed rows of large cone-shaped bumps running down the animal's back and sides, interspersed with smaller, irregular scales, a texture completely unlike the smooth or feathered coverings often imagined for large predatory dinosaurs. It gave scientists something they almost never get: direct physical evidence of what a big, dangerous theropod dinosaur actually looked like on the outside, rather than an educated guess based on skeleton alone. This discovery became a key piece of evidence in the broader scientific conversation about which dinosaur groups had feathers and which didn't. Because abelisaurids like Carnotaurus show clear, scaly, bumpy skin with no trace of feather structures, they've become an important reference point in understanding just how varied dinosaur skin coverings really were, even among fairly closely related predatory groups. Unlike many famous dinosaurs known from dozens of specimens, the entire scientific understanding of Carnotaurus rests on a single skeleton, unearthed in a single expedition. In 1984, Argentine paleontologist José Bonaparte, one of the most influential dinosaur hunters in South American history, led an expedition into the La Colonia formation of Chubut province in Argentine Patagonia. The dig took place on a remote ranch, and the landowning family who granted access and support to the expedition, the Sastrei family, would later be honored in the animal's scientific name, Carnotaurus sastrei. What Bonaparte's team uncovered was remarkable: a skull, much of the skeleton, and, crucially, large sections of fossilized skin impressions, all preserved together in a single articulated block of rock. Bonaparte formally described and named the animal in 1985, and the discovery was significant enough that it remains, to this day, one of the most complete and best preserved large theropod skeletons ever found anywhere in the southern hemisphere. Here's what makes Carnotaurus scientifically unusual. More than 30 decades after its discovery, that original 1984 skeleton remains the only confirmed specimen of Carnotaurus ever found. No second skull, no juvenile skeleton, no additional bones from a different individual have ever been definitively identified. That single specimen status means every museum skeleton of Carnotaurus you'll ever see on display in Argentina, in the United States, in Europe, anywhere in the world, is either a cast, a replica, or a reconstruction based on that one original animal. It also means basic questions that are easy to answer for better represented dinosaurs: how much individuals varied in size, how the animal changed as it aged, whether males and females looked different, remain for Carnotaurus largely unanswered. Every new fragment potentially found in the La Colonia formation carries the chance of finally giving paleontologists a second data point for an animal science has only ever seen once. One of the most debated questions about Carnotaurus is how fast it could actually move. Its legs were notably long and slender relative to its body, with a lightly built lower leg and foot, proportions that in living animals are often associated with speed and endurance running rather than raw power. Early biomechanical studies by Bonaparte and later researchers proposed that Carnotaurus may have been among the fastest large theropods known, with some estimates suggesting running speeds well beyond what most big predatory dinosaurs could achieve. More recent analyses have offered more conservative numbers, cautioning that estimating dinosaur running speed from bone proportions alone carries real uncertainty, and that factors like soft tissue, muscle mass, and body posture are difficult to reconstruct with confidence. What most researchers do agree on is this: whatever its exact top speed, Carnotaurus was almost certainly built as an active pursuit-style hunter, likely chasing down fast-moving prey across the open floodplains of late Cretaceous Patagonia, a very different hunting style from the ambush ferocity often imagined for heavier-bodied predators like Tyrannosaurus. When a full-scale Carnotaurus mount is put on display, it tends to stop visitors in their tracks. Not because of raw size, but because of how unfamiliar it looks. The deep, blunt-horned skull, the impossibly small arms, and the long, whip-like tail all combine into a silhouette unlike almost any other predatory dinosaur on public display. Because only one true skeleton exists, most of these mounts are carefully sculpted casts built from detailed scans and molds of the original Patagonian specimen, then distributed to museums around the world. Even so, every one of them ultimately traces back to that single dig site in Chubut province in 1984, meaning every visitor standing beneath a Carnotaurus skeleton anywhere on Earth is, in a very real sense, looking at a reflection of that one extraordinary discovery. Even with such a well-preserved skeleton, Carnotaurus remains full of open questions. We've already touched on two of the biggest: what its tiny arms were actually for, and how fast it could really run. But there are others. Paleontologists continue to debate exactly how those distinctive brow horns were used, whether primarily in combat, in display, or in some combination of both. There's also ongoing discussion about how Carnotaurus fits into the broader Abyllosaurid family tree, and how closely it's related to other horned or crested South American and Madagascaran predators like Allosaurus and Majundasaurus, relationships that could shift as new abyssosaurid fossils continue to emerge across the former continent of Gondwana. And of course, there's the biggest open question of all. What would a second Carnotaurus skeleton reveal? Until one is found, everything we know about this animal, its size range, its growth, its variation, even parts of its exact anatomy, rests on the shoulders of a single individual pulled from the Patagonian Badlands more than 30 decades ago. Carnotaurus has become one of the most recognizable predatory dinosaurs on Earth, not because science has studied dozens of them, but because of how strange, distinctive, and complete that single skeleton turned out to be. A skull like a bull, arms smaller than a human child's, skin preserved well enough to show us for the first time what a giant meat-eating dinosaur's hide actually looked like. From a remote ranch in Chubut province in 1984, to museum halls around the world today, to unanswered questions still waiting on a second specimen, the story of Carnotaurus is a reminder that sometimes one extraordinary fossil is enough to change what we think we know about an entire group of animals. If you enjoyed digging into the real science, the real discovery, and the real mysteries still surrounding Carnotaurus, make sure to hit that subscribe button, because we uncover a new fossil story like this every single week. Drop a comment below. What do you think those tiny arms were actually for? Leftover evolution, or something we haven't figured out yet? Let's debate it down there. And if you want more deep dives like this one into strange, record-breaking, and scientifically controversial dinosaurs from around the world, hit that like button, and I'll see you in the next one.